Today we are doing our second review day. We are going to cover order of operations and grouping symbols. So our objective is to simplify expressions with and without grouping symbols. Again, this should be a review. We shouldn't necessarily be covering anything that's brand new to you. We just got to make sure that we all start off on the same page. All right, in our warm-ups, we are simplifying the expressions. So we are going to follow our order of operations. Does anyone remember what letters we use to help us remember our order of operations? Z.
Please excuse my dear Aunt Sally.
Yes, that is a mnemonic for it. So the letters... Wonderful. So some people say it PEMDAS. Please excuse my dear Aunt Sally. Whatever it takes for you to remember those letters and what they stand for. Parentheses, exponents, multiplication, division, addition, subtraction. Something we will talk about more today is that multiplication and division are technically ranked the same. So are addition and subtraction. They are ranked the same. So we do them from left to right. All right, so let's move on to our warm-ups. The first thing that we should do on warm-up number 1. Jordan?
5 times 4.
5 times 4 is 20. So we end up with 9 plus 20, which is 29. Good. I hope it is easy. On number 2, the first thing I need to do. Dominic?
4 times 4.
Good.
In the parentheses, by the way.
Yep, 4 times 4 is?
16.
16. Good. So we have 18 minus 16, which is?
Negative 2.
2. 18 minus 16 is 2.
Oh my god.
All right, on number 3, the first thing we need to do.
22 minus 7.
Good. What's in parentheses? 22 minus 7 is?
18.
15. When we see a fraction bar like this, what operation does that tell us to do? Division. 15 divided by 5 is? 3. All right, number 4, I need to start again in my parentheses. 6 plus 12? 18 divided by 9. Anybody? 2. Good. All right, in our notes for today, a grouping symbol is a device, such as parentheses, used to enclose an expression that should be simplified first. So we have 3 major types of grouping symbols that we will see: parentheses, brackets, and fraction bars. Parentheses are the ones we are usually most familiar with. Those are the ones that we saw in our warm-ups. So that would be something like 2 divided by 1 plus 1. We use parentheses to show that the 1 plus 1 has to be done first. Brackets are very similar to parentheses. They just look a little bit different. So that would be something like 5 times 7, use my brackets, 7 minus 2. So brackets look a little boxy, whereas parentheses are more round. We did see brackets in our notes for simplifying on day 1 also. They use some brackets sometimes. Fraction bars are the ones that we are least familiar with using as grouping symbols, because fraction bars usually just make us think of what operation? Dominic?
Division.
Division. But fraction bars can have two jobs. They can be division symbols, but they can also be grouping symbols. So for example, if I have 18 plus 2, all of it divided by 5, that means that the 18 plus 2 has to happen first. So if you need, most of the time we understand parentheses and brackets better, but if you need to make yourself a note on this one, 18 plus 2 comes first because the division bar works as a grouping symbol. It groups the numerator separate from the denominator, or the top separate from the bottom. This note at the bottom should go in our notes off to the side. If there's more than one grouping symbol, simplify the expression in the innermost grouping symbol first. Then work towards the outermost grouping symbol until the expression is in simplest form. So the big idea here is we work inside out. All right, there is something about number 1 that I'm going to make a little bit of a big deal about. Okay, so the first thing we need to do is in our parentheses. So 8 plus 3 is 11. That's the only thing that's changing right now. So what do I need to make sure I put around the 11? Parentheses. That is not turning into 511. What do the parentheses tell us to do in this case? Multiply. So our last step is to multiply, and what do we get? 55. Okay, so I make a big deal about the fact that just because we have two numbers written next to each other, they do not magically turn into some new number. The parentheses there tell us that we have to multiply. And 55 is our final answer. That is as simple as it gets. Now on number 2, what would you do first? 5 times 8. Okay, there's nothing to do inside of the parentheses. There are no exponents, so next up is multiplication and division. So we multiply 5 times 8 to get 40. Then we add the 3 to get 43. Do these have the same solution? Did we get the same number?
Oh, no.
No. These do not have the same solution. Why did our answer change?
Because one was adding and the other one was multiplication.
So they both used addition and multiplication at some point. I think Breon's got it. What was it, Breon? Good. The parentheses are in different places. So the parentheses changed. So that is why our answer was different. Oop. There we go. The parentheses changed, therefore our answer changed. The numbers were in the same order. We used the same 2 different operations. But because of where they stopped the parentheses, it changed our whole problem. So if our fraction bar is splitting us into a top group and a bottom group, we can do each of those at the same time, but they have to be done separately. So that means I've got to do 10 plus 6 to give me 16. Then I have to do 10 minus 2 to give me 8. Then, now what is the fraction bar doing after that? Dividing. 16 divided by 8 is 2. If you want, when you see a fraction bar, just put big parentheses around the top and the bottom. If that helps you remember those groupings, you can do that. On number 5, how many sets of grouping symbols do we have? 2. We've got a set of parentheses and we have a set of brackets. Good. So when we have multiple grouping symbols, where do we start? Inside, in the middle. Sometimes it's kind of towards the end of the problem, but we start inside as much as we can. So we're going to start with the 8 minus 3. That means that nothing else about this problem is changing except for the 8 minus 3. So I rewrote everything else. That's what I expect you to do also. 8 minus 3 is 5, so that's what I'm going to put there instead of 8 minus 3. Okay, now what do I need to do?
You got to do it inside of the bracket.
Do inside the bracket. So 10 divided by 5 is 2. So I kept the front part of the problem the same and replaced the brackets with a 2. My last step is 10 minus 2, and that gives me 8. When there are no grouping symbols, simplify in this order. First, do all multiplication and division in order from left to right. Then do addition and subtraction in order from left to right. So this should be going in our notes. You can shorten this up pretty easily. Okay, so if you want to reword this to shorten it up, that's fine. Just make sure you're getting the same idea across. So we can see on these examples there are no grouping symbols. No parentheses, no brackets, no division bars. So we have to decide what order things are going to happen in. And in general, we're only going to do one operation at a time. Meaning we're only going to change one thing about the problem at a time. Number 6. What piece of this needs to happen first? Liam?
8 times 2.
Good. 8 times 2. So we know we have to start with multiplication and division. So we start scanning our problem from left to right. And the first thing we come across is multiplication. So that's the first thing that'll change. Everything else is staying the same. And instead of 8 times 2, what am I going to write? 16. What has to happen next? Good. 16 divided by 4 happens next. So everything else stays the same. Except 16 divided by 4 is 4. What happens next? Janaya? Good. So now we're done with multiplication division. We move on to addition subtraction. We still work left to right. 3 plus 5 is 8. Last step is to add the 4 and we get 12. So I tried to underline every step that I did as I went. If you want to use squiggly underlines so that they don't look like fraction bars, you can do that. Use squiggly underlines instead. So one step at a time. Yes, many of you are probably capable of doing that problem much quicker than we did it together. And I understand that, but I do expect to see your work shown. On number 7, what operation happens first? Good. The multiplication, 15 times 4 is 60. This one's pretty straight and simple to the point because our last step is just to add, and we get 89. Questions, concerns about those simplify problems? All right, we'll keep it moving. What's the first thing we did? Andrew. Good. 12 times 2 should happen first. So everything else stays the same. 12 times 2 is 24. What happened after that? James? Good. 24 divided by 8. What is 24 divided by 8? 3. So notice that none of my operators changed as I'm doing this. Everything else stays the same except for the one piece that I'm changing. What should happen next? 19 minus 7. Why? Janaya? Ooh, I agree with 19 minus 7. Why is that? Because it comes first from where to where? From left to right. So addition and subtraction are ranked the same. They have the same weight. They have the same seniority, however you want to think about it. They are the same, but we have to do them from left to right. So that is why 19 minus 7 has to happen first. And what do we get? 12. And then 12 plus 3 is 15. So on number 9, what did we do first? Janaya?
8 divided by 2.
Good. 8 divided by 2. That would give us what? 4. Then we add and we get 7. Good. On these problems, I would write down the directions. I would write evaluate, if, and then all of that back there. You don't necessarily have to write the words each expression if you want to make it as short as possible. Evaluate if A equals 4, B equals 7, and C equals 10. That will apply to both of these problems. When we evaluate, I mentioned this yesterday, it's important that we remember that we have to plug in or substitute, then simplify. We've already talked a little bit about the fact that a number right next to a letter or a variable means that we have to multiply those things. So how would I symbolize that when I plug in for my variables? How can I make sure I don't think that that's supposed to be 44, James? Good. Parentheses would be my favorite way. If you were to use a multiplication dot, that's fine. If you use a little multiplication x, that's okay, but in this class, x's are usually reserved for variables. But you need to do something to make sure that you know that 4 is getting multiplied by the 4 that goes in for A, and 2 is getting multiplied by the 7 that goes in for B. Deshaun?
Oh, you talking about for 11?
Nope, for 10. What operation do we do? Annabelle, can you help us out?
I mean, it's 4 times 4.
Good. 4 times 4 comes first. Multiplication from left to right. 4 times 4 is? Then what would I do next?
2
2 times what?
2 times 7.
2 times 7. Good. So do not subtract. We're not done with our multiplication division step. Do not subtract yet. We got to get all the multiplication and division done before we do any addition or subtraction. My last step is to subtract. 16 minus 14 gives me what? 2. Questions, concerns? This should be review, but hopefully we're catching little mistakes we might have made before when we learned this. Are we ready for 11?
Yes, ma'am.
Great. In my numerator, what am I going to write? The top of my fraction. Dominic?
Oh. 3 parentheses 4 over 10 minus 4.
Good. Gave me the whole thing.
Wow.
Beautiful. Okay, we don't really need parentheses around the 10 or the 4 in the denominator because we are not multiplying to either of those. So first step is to plug everything in. Do we have any grouping symbols here? Yeah, what do we have? The parentheses, sort of. The parentheses here are more for multiplication. Janaya? The fraction bar is a grouping symbol. It groups the top together and it groups the bottom together. So that means I do have groups to do first. My top group is 3 times 4. That gives me 12. My bottom group is 10 minus 4. That gives me 6. I've only got one operation left, and that is to divide. 12 divided by 6 is 2 also.